Hi there, geometry students. Today we're going to start talking about two-column proofs. And as we introduce two-column proofs, we're going to be doing what I call fill-in-the-blank proofs, where you're filling in parts of the proof, getting comfortable with the patterns of the proofs before you go to the next step of having to write your own two-column proof. When you do proofs, you use deductive reasoning in your proofs. And I asked you what the difference between deductive reasoning and inductive reasoning was. We've been looking at both of these. Remember, deductive reasoning is where you're using a thought process that involves facts, rules, definitions, postulates, and then you come to your conclusions. So that's what you're going to use when you're dealing with proofs. Remember, inductive reasoning is where I had that stomach ache and I kept getting stomach ache. So then I drew the conclusion that whenever I eat pizza, I get a stomach ache. So we're going to use deductive reasoning to do our proofs. When you write a proof, I put a picture, the proof back from when we did the algebra proofs in the last section. When you did algebra proofs or did an algebra problem, you always took and you wrote what your teacher gave you down, and then you did a number of steps to arrive at the final answer. And as you were doing each of the steps, you were actually following rules and regulations and using your deductive reasoning. When we go to do our geometry proofs, we're still going to have to list our givens. If there's no picture, I suggest you draw a picture of the line segments or the angles. And then you're going to use your deductive reasoning to write the proof, following your rules and your regulations and writing it out step by step. A lot of times as we start to do our two-column proof, and this is a two-column proof here, people. I got my statements and my reasons. As we go to do the two-column proof, a lot of students will say, well, what can I write in the reason column? Well, you can write your givens in the reason column. Postulates or properties. That's what we were doing over there, multiplication property, division property. Postulates would be angle addition postulate, segment definition postulate. You're going to use your definitions, like definition of midpoint, definition of congruent. And then we haven't got any theorems yet, but we'll use our theorems. Those are proofs that we've already written, and then we're going to use them because they're going to create shortcuts for them. So we're going to use proofs we've already written within another proof to shorten up that proof is what we're going to do. All right, let's take a look here. First thing I like to do is review segment addition postulate and angle addition postulate. Remember, segment addition postulate is where you add the two pieces together to get the whole line segment. And so I have segment AC, and that equals the AB plus the BC. That equals the whole entire segment AC. Angle addition postulate. I know that you don't have that on your paper, but you probably can sneak it over on the right-hand side by the first proof. Angle addition postulate is where you add those two small angles together to equal the whole entire angle. And so in my picture, I'm going to take X, Y, T. I'm going to add it to the measure of TYZ. It's going to equal the whole entire angle, which is angle XYZ. So let's quick review of the two postulates that we've covered. Let's take a look at the first example. You're given BC equals DE. So when you go to do your geometry proofs, you're going to do exactly what you did in algebra. You're going to write your given down. And why did you write it down? Because you were given it. Next, you take your proof. I want to prove that. So that should be the last thing you say. This is what I have. So down at the end of your proof, you should be writing what you're going to prove at the end. And when we go to write a full proof, where we have to do the statements and the reasons, we will be doing that. All right, now we need to fill in the gaps. If I want to talk about AC at the end, AC is not in number one anymore. I need to introduce AC. So I need to introduce AC here. When you're introducing AC, look at the picture. AC equals AB plus BC, and that equals AC. Now, I specifically need to write this way because do you see how things are lining up here? AB is lining up with AB, and AC is lining up with AC. Things need to line up, people. So make sure you pay attention to that. If they don't line up, you're going to have to do some rearranging, and that's switching things around, which is the switching around property, which is symmetric. What happens from 2 to 3 now? What has changed? This BC has changed to DE. BC is the same thing as DE, so I have taken it out and put DE in its place. That is a substitution. Let's take a look at our next proof. This one is from the book, and I'm not really a fan of it because I always take all of my givens and I'll write them right at the top of my proof. The book example here has spattered them throughout, so it can be confusing. Q is between P and R. They've written it in the number 1 spot, and they wrote given. R is between Q and S. R is between QS is written in number 3. So that came from the given. Then I have PR equals QS, and that's in the number 5 spot. So that is going to be the given. So do you guys see here? I like to put all of my givens on the top, and that's the way I'll do it all the time. This example, they've spattered them throughout, so just be cautious on that. Then what I would do if I was writing the proof is I would take my proof and I would go all the way to the bottom and write it down on the bottom, because that is the last thing I want to say is PQ. So I need that in A. PQ equals RS. Okay, now let's go back up to the top. If Q is between P and R, then I can take the 2 pieces, PQ and QR, and add it to PR. So when you add 2 segments together to get the full segment, that's called the segment addition postulate. Next, they are saying you have R between Q and S. So do you guys see QR and RS equals QS? QR and RS equals QS. That's another segment addition postulate. In number 5, they have given us PR congruent to QS. I'm looking from 5 to 6. PR is no longer there. PQ and QR are gone, are there, and PR is gone. Do you see here? Here's PR. PQ and QR have taken its place. Same thing with QS. QS is gone. QR and RS have taken its place. That is called a substitution. What happens from 6 to 7? Do you see here that QR minus and the QR minus is added from 6 to 7? So that is called the subtraction property. And then from 7 to 8, what they said is, you're now taking this, it's gone, there's a 0 there, and the QR minus the QR is gone, there's a 0 there, so they've done a substitution. Number 4, let's take a look at this one. Complete the proof. So again, I'm going to take my given, PR congruent to QS, PR congruent to QS. That's my given. Then I'm going to take my proof, PQ congruent to RS, and I'm going to write it down on the bottom, PQ congruent to RS. All right, let's go back up to the top now. What happens from A to B? What's the change from A to B? Okay, they changed the congruent to equals. Definition of congruent means equals. So when the congruent changes to an equal sign, that is definition of congruent. In letter C then, what they're doing is they're saying, okay, if I want to talk about PQ at the end, I need to introduce it. So they're introducing PQ in letter C. What they've done is they've taken PQ and QR and added them together to get all of PR, and that would be called the segment addition postulate. Again, in letter D, they want to use segment addition postulate. Here's QS, so they want to do segment addition postulate with QS. QS is QR plus RS equals QS. What they've done next is PQ and QR are the same thing. See that right here? They're the same thing as PR. PR is right here, so I'm going to take PQ and QR and I'm going to write it on the right-hand side. I'm not going to have PR there. I'm going to write PQ and QR in its place. Same thing over on the QS. QS is the same thing as QR and RS. So instead of QS, I'm going to write that on the right-hand side. So that would be a substitution. All right, now when I look at E and I look at G, I got PQ. All right, I'm happy that's PQ, right? That QR has to disappear. I'm looking at RS on the right-hand side. I've got RS on the right-hand side. This QR needs to disappear. So I need to get rid of the QRs. How can I get rid of those? Well, they tell you you're going to subtract them off of there. So when you subtract them off there, you're left with PQ equals RS. From F to G, the equal sign changes to congruent. So that's going to be definition of congruent, and you don't need to write congruency of segments. Definition of congruent is fine with me. Now, you guys have two proofs left, I believe. They're both angle proofs. If you could try to do these on your own, try and fill in the reasons, and then tomorrow when we come to class, I will talk about them. But try and do them on your own. See how much you're able to complete without Mrs. Hefty's help. So you have this proof, and you have this proof to try and do on your own, and then we can talk about what the reasons are and what the patterns are in those proofs. So you guys have a great night, and I will see you in class tomorrow.